All right, let's go ahead and finish up chapter 1, section 3. We talked about linear functions. And they look like this. And we're going to look at other forms of linear equations. So then we looked at horizontal and vertical lines. A horizontal line looks like that. A vertical line goes up and down. Certain characteristics exist for horizontal and vertical lines. Horizontal lines, or if we need 2 points for a line, they have the same y values. For example, in this one, there's x1, and any x's you pick, it'll give you the same line. This is x1, this is x2. For vertical lines, they have the same x values. In this example, so for any 2 points, the x's remain the same. Another thing, the slope of a horizontal line is 0, and the slope of a vertical line is undefined. This is important because, as we'll see in a little bit, we'll be looking for equations of lines, and it'll say, so undefined, the slope is undefined going through this point. What's the equation? And we got to find it. Also, last time we talked about the slope. Slope, by definition, people describe it as rise over run. That's typically how people define slope. But it's not really true, because on the top, you can have rise if the slope is positive, or sink if it's negative. Or as it goes up if it's positive, it goes down if it's negative. The run is always to the right. The variable we use for slope is m. The formula is the change of y over the change of x. That's our formula for the slope. So, like in example 2 in the sheet I gave everybody here, how would you draw a graph that looks like this? Or like this? Draw the graphs of the following equations. I use the term equations, not functions. Why? What is a function? How do we know what a function is? Each x value corresponds to one and only one y value. So it has to satisfy the vertical line test. If the vertical line crosses more than one point, then it's not a function. What's the graph of this one look like?
At point -2, 0, that's where the line crosses.
Well, we need a couple of points. Yeah, so our first one, x is what? -2. So we put y is 0. X, second point, x is -2. Let's say y is 2. Since the only point you have is x, at -2, y is 2. So it's a vertical line. Likewise, this next one, y equals 5/2, which is 2.5 or 2.5. Which is right there. So we need a couple of points. Y is always 2.5. X can be 0. X can be -2. But y is always 2.5. So at 0, it's 2.5. At -2, it's 2.5. So it's a horizontal line. Which I should have also put on the bottom of the last page. If all your x's are -2, no matter what y you give me, it's always at -2. All right, so back over here, you have horizontal and vertical lines. This is the horizontal line. They have the same y values. The equation of the line is y equals whatever that number is. The equation of a line that's vertical is it's whatever that x number is. So if you have a horizontal and vertical line, it's once you understand these concepts here, they're super easy. If you look at 2 points, if they're the same y values, you know it's a horizontal line. You know the equation of the line, it's that equation, that number, and the slope is 0. It seems pretty straightforward. It is straightforward. It's pretty easy once you look at it. Let's look at a couple of applications. In the real world, slope is also referred to as the grade or the gradient. We talked about last time the slope of a handicap ramp, which is for every 1 foot up, it's got to be 12 feet out. for a handicap ramp. Downhill skiing. If you've ever been skiing, you have certain types. Green, blue, black. So whereas this one, it's very, very, very shallow. You can't go too fast if you lose control. Then it gets a little bit more steep. Then the black, then you go to diamonds and double diamonds, which are practically vertical. Like, for example, look at the picture I have in the sheet for you. Here's horizontal ground. That's the slope of the mountain. They hit speeds around 70, 80 miles an hour. So it's pretty steep. All right, let's look at example number 3. Curb ramps. Curb ramps provide independent access sidewalks to those wheelchairs. Guidelines says that it has to be between 5.9% and 8.3% by federal law. Federal law states that every vertical rise of 1 foot requires a horizontal run of 12 feet. So how would you determine if remember 1 foot and 12 feet, that's pretty large. How would you determine if the curb at your nearest corner, if it's within regulation? Remember, it's not 12 feet long. The curb's only, 3 feet wide maximum. What in this equation would help us determine that? The percents. Because let's say the curb is only raised 3 inches and it goes out 24 inches, 2 feet. Is that a valid legal ramp for handicaps? How would you determine that? Is it between 5.8% and 8.3%? How would you determine that? Well, what's the formula for percent? We have to understand what percent means first. What's the formula for percent? Not right? It's going to be decimal, and we just convert it. So, but the formula for percent is the part over total times 100. Whatever you get there is your percent. Now, how do we take this percent equation and convert it to a slope? Look at the fraction. Do we deal with fractions and slope? Of course, yeah, of course. What's the formula? Yeah, y over x, rise over run. So in our case, it would be 3 inches over 24 inches times 100. We can simplify. 3 goes into 3 once, 3 goes into 24 8 times. So we have 1/8 times 100. In your calculators, what is that going to give us? %4.5. So is that a legal ramp? No, because it's outside the range. Was anybody gonna complain about it? No, because it's not that steep of a grade. So, but this is the number they're looking for, is the y over x, which is the part. This is the y over x, the part over total. The rise over the run. All right, let's look at example 4. Food stamp program. The number of people participating in the federal supplemental nutrition assistance program has increased from 17.2 million in 2000 to 47.6 million in 2013. If there is no graph, find the average rate of change of the number of people using food stamps from 2001 to 2013. Let's see what we have here. So we know that there was 17.2 million in 2000, and it jumped up to 47.6 million in 2013. What's the average rate of change of that data? And it goes up 17.2 million. Twenty 2014, 2013. Why'd you put these down here? Number 4. Last page. It's easy. Whenever you deal with time, everything deals with time. Time always goes on the x-axis. Time is always an x-axis variable. The reason for that is it never stops. Remember the rise over run? The run always goes to the right. Time can never go backwards. So it always goes to the right. So time is always, another way you can think about it. What's the dependent variable? Bless you. What affects the other? The year affects the number of people. So what we have here, we have the point 2000, 17.2, and the point 2013 at 47.6. We have our 2 points. Now we can label our y1, y2, x1, x2. X1 is 2000. Y1 is 17.2. X2 is 2013. Y2 is 47.6. So the rate of change or the average rate of change is y2 minus y1, x2 minus x1. So 47.6 minus 17.2. 2013 minus 2000. $30.4 over 13. What was that equal? Three. So what does that tell us? What does this number tell us? We found the average rate of change. What does that tell us? No, what it tells us is each year there's an increase of 2.3 million people on getting on food stamps. That's what it tells us. Because we had 13 years on the bottom. And so we look at per year, what is it going to be? So 2.3 million more people go on food stamps. That's what it tells us. So you see, the same thing goes in example number 5. Oil imports. Increase of oil production in the United States has resulted in a decrease of imports of crude oil. The total number of barrels imported in 2008 was 3,590,000. The number decreased in 2,810,000 in 2013. So we set it up the same way. The time goes on the bottom. The number of barrels goes on top. Y2, Y1 over X2, X1. All right. The slope intercept equations of lines. Yeah, I don't like the way the book did this because there are 3 types. The point slope should have been the first one, not this one. But this is the textbook. Slope intercept. Slope has what letter? The intercept. Which intercept are we talking about? Yeah, when we say the intercept, in this case, it's the y-intercept, where it crosses the y-axis. The letter we use for that is B. And that's the slope intercept formula. So when it says y, what is the y-intercept? The answer is what? No. The y-intercept is a location. So it's going to be 0, B. You're right. It is the number, but when we answer the question, when it says, what is the y-intercept? You have to put it in order pair because it is a location. Because they're going to ask you 2 different ways. One of them is going to be the ordered pair. That's the y-intercept, the location of the other numbers. At what point, what number is the y-intercept? So if I give like example number 6, if I give you an equation like this, and I ask you the slope and the y-intercept, what would the answers be? What's the slope? Right. The slope is whatever is in front of the x, which is negative 0.25. Very good. And the y-intercept? Very good. That's exactly it. Because anything after the x, the constant is the y-intercept value. All right, let's look at example number 7.
I'm sorry, and the intercept was the negative.
0, comma, negative 3.8. The y-intercept is always the constant in an equation. So same questions here. What is the slope? And what is the y-intercept?
Anything before the X is.
No. It has to first be in what form? Is it in y equals mx plus b? Right now it's just it's an equation. It means nothing to us. You have to always solve for y first. Because it has to, before you do anything, it has to be in this form, y equals mx plus b. So you have to solve for y. Okay, so how do we solve for y? What do we do first? There are 2 ways you can go about this. Let's see if you think about the easier way. Just 6. That's one way. You could move this and this out of there. So let's look at both ways. We can subtract 3x from both sides. And we can add 7 to both sides. Those cancel. And then what? Whoever taught you how to divide by negative numbers should be shot. They should be fired. They should never teach math again. Never divide by negatives. Well, you can do it, but your chances of making a mistake with signs is going to increase exponentially. If you get into this position, and that's the negative, we get rid of the negative, treat the signs and the numbers separately. In other words, we want to get rid of the negative. So just change all the signs. When you're doing your own homework, you can do what you want to, but I guarantee you, you will have more chances of making a sign error than anything. Because when you divide by negative, you have these 2 equal signs and you have a negative. Like it's just many signs everywhere. Because that's if we divided, well, that's what we'll do on this side. If we divided by negative 6, look at all those lines there. So then you have to make sure. Three and a six. And then what do you do there? There's just a lot of mistakes. Again, treat the signs and numbers differently. Don't ever, if you want to succeed and increase your chance of making the right answer, treat the signs and the numbers separately. Because all you have to do now, everything's set up the way you want to. All you have to do now is just divide by 6. That gives you y equals 1 over 2x. It already tells you what sign goes there. There's 0 you have to think about. It tells you what to do. But if you divide by a negative number, you're going to forget it somewhere. And in mathematics, if any one sign is wrong, the whole equation's wrong. So that's one way of doing it. Another way, again, you weren't taught this in high school because you always want to make sure that the x's or y's are on the left side, everything else on the right hand side. Doesn't have to be. If x equals 3, doesn't 3 equal x also? So it doesn't matter where it is. Here's what you should do. Since you're solving for y, and it's over here, and it's got a negative, move that over. How would you move negative 6y over? Add 6y to both sides. Do you have to worry about negative sign now? No. All you have to do now is divide by 6. Each term by 6. So 3 and 6, so it's 1 over 2x. Now, if you want to, you could rewrite it as y equals 1 over 2x minus 7/6. Again, through this course, I'm going to show you ways that you've been taught wrong in the last 12 years of your life. To minimize the chance of getting a mistake. I mean, it's not wrong. You can divide by negatives all you want. But again, your chance of making a mistake, of forgetting where one of the signs go, increases exponentially. So avoid the signs. How would we graph? A linear equation in slope-intercept form? This is example 8.
So the last example, we were just supposed to find y.
You have to solve the equation. Well, then, okay, what's the slope? Yeah, the slope is 1/2. The y-intercept at 0, negative 7/6. Graphing linear equations, if it's in this form, is very easy. To do this, here are your steps. Plot the y-intercept, plot B. So where's B? 1, 2. So it crosses at 4. Yes. What does my slope tell me to do? Yeah, it says, remember, if there's a negative in front, it always belongs to the top number. Because the bottom number is always positive and always goes to the right. So from this point, from B, follow the slope, follow M. So go down 2 and over 3. This is -2, +3. Connect the dots. And there's your graph. Pretty straightforward. All right, that does it for section 3.